Scene transition. Nope. Scene transition. There we go. Starting with kind of like the general, where do they go? Career trajectories of physics majors. Hey, where do they all go? I don't know. I mean, it's kind of true though, because how many times are you like, hey, what did you get a degree in? The person's like, physics. Like, or how many times are you asking someone like, hey, what do you do? And they're like, oh, I'm a physicist. And then you immediately don't assume that they work at a university. Because you're gonna assume they work at a university. It's just kind of like what you think when you hear someone say, I'm a physicist. You think I work at a university or a think tank or something like that, you know? But like, how hard is it to get into graduate school, or rather, what factors are most important to get into graduate school? All discussion is appreciated, though. Okay, so let's start with that stuff, and then I guess let's start here, and let's kind of like work our way there. So if you look at this figure right here, let me kind of whoops, use my fingers to zoom in here. Okay, so if we look at this, we can kind of see like a little breakdown of what happens. Oh, I think the AIP statistics is good. Hold on. Unless it's not good. Oh, never mind, it's not good. Well, we'll hold that and do it later. Okay, where were we? So we can kind of like see like what's going on a little bit right here. We're like, it's great in the sense that only 5% are unemployed. Okay? But then as far as like what goes on with the rest, like that's like, this is decent stuff. Like 41% are employed. That's great news for physics majors. If you are a physics major, to see this number and to see like that 41% of you know, physicists, if you graduate with a physics degree, you're a physicist, you know, you're getting paid to do physics. Whether or not you become an engineer or whatnot is a completely different story. But like 41% go into a workforce. They go into industry. They go into government. They go into some still work in academics as like lab coordinators and things like that. That's like my lab coordinator at BU, I think just has a bachelor's degree. He might have a master's. I don't think he has a PhD. Maybe he does, but I don't think he does. Either way, he's one of the smartest and most he's certainly one of the most technically inclined people that I've ever met in my entire life. And he does it all while teaching physics, which is completely like boss. And I'm pretty sure he does not have, I used the word boss as an adjective. We're bringing it back. Well, we're probably not bringing it back. That might be the only time I ever say it. He is so good at his job. So like in the employed section, you have everything like that. From like just computer programming, from data analysis, from government work and doing actual like physics as a, you know, with a bachelor's degree. When I physics and a BS in math back in June and have a few other credentials and have been unemployed and looking for work since. Interesting. That's kind of surprising. Did you, I mean, are you, let's see, how do we want to proceed with this? What are you looking to do? Do you know what you're looking to do? Like, are you looking for something very specific? I just don't know if that's what you want to do. There's always that. Like, when you graduate and you're young, you shouldn't just immediately just jump into something you don't want to do. As long as you can, like, you just get a job, like a part-time job. Or, you know. Yeah, there's certainly an aspect of like not wanting to rush into something that you don't want to do. And that, if I could turn back time and graduate on time like I was supposed to, and, you know, not going to graduate school, like we're talking like 10 years ago, then there's certainly a part of me that would be like, I should probably not rush off into school. I should look for a job that I'm going to be happy at. Or at least, you know, that I can find advancement at, that I can like be at for a very long period of time. But I'm surprised to see that. And I mean, like, so like I've heard very strong things about people who graduated from school with physics. And looking at the, you know, looking at this graph, it seems to be like the majority of people who graduate, I mean, 5% are unemployed. Most of them are finding jobs. The employed is just for the private sector, is what it means by that. Or I mean, I guess it could be public sector too, but it would just be like, industry as opposed to graduate study, which is the other half of this. But like this is kind of like the breakdown of where they go, and like you can see the private sector, which would include like marketing and things like that, and then you can see the the rest of the college and university, which is a lot smaller percentage than up there. Huh? Oh, college and university would probably still be like industry style. Yeah, and like the government work and the contractors is where you really do get money, and they really do hire bachelor's degrees too. Those are a little bit more challenging to get, I think, and you have to be 16 years of experience. This is over near. Yeah, I don't know what the job market's like there. It might be. Did you do an internship? Because like I know internships are really important for finding jobs in industry after school. If you don't go to graduate school. Anyways, like that's neither here nor there because you were interested in graduate school. So let's talk about what it means to get into graduate school, okay? So there is this whole mentality of like, here we go. This might be interested too if anybody's interested in just bouncing with a bachelor's degree. But like these are the skills regularly used. You work on a team. If you've done any research, if you didn't do any undergraduate research, you need to do undergraduate research, and if you want to go into industry, you should really have an internship. But if you don't want to go into industry, then internship is completely not necessary. And but you should do one of the two, if not both. So I can't stress, and I always tell my students who are talking about graduate school, or even a lot of them who are talking about industry, and they're mostly engineering, they're almost all engineering. Oh, that's an easy question, Jax. You just ask. You just go up to people and start asking. You say, I am interested in what you do. You look at a few papers. Now, your situation is a little bit different because I think you said that you were mostly distance learning, right? And like not just because of, the COVID-19, but you're mostly distance learning. Like you're mostly distance learning, right? But yeah, if you have someone at your university that you're interested, and NeuroJalen can speak to this because you even said you were working on stuff, For me, my experience was look up someone who does an interesting topic. Yeah, so yours might be a little bit more complicated. You might just have to take some different angles when approaching professors to research with if this is what you're interested in doing. But you'd have to be like, like I've taken this class with you. You might have to be actually very specific about a professor. Be like, look, I took a class with you. This is something, that I'm interested in. What can we do? And then distance learning would just have to be like that would just have to be the method of research as well, which is not unheard of. It's not unheard of at all. But the idea is you go up to one of your professors that you've preferably taken classes with, because then kind of like what they're like to work for a little bit, because you're technically going to be working for them, especially if you're in graduate school. It's not going to be technically. You will be working for them. And then in graduate school, if you're not getting paid by them, it's kind of more like you're technically working for them. It's not like really literally working for them. But if they're paying your research funding, then you're literally working for them. So you want to make sure you kind of have somewhat of an understanding of who they are, okay? And then you go to them and you find what topics they've worked on. And then you say, I'm also interested in those topics. I have read, such and such of your work. Like, actually look at the things that they've put out. Because your next few papers that you write with them could look just like that. So you want to make sure that you know what they've done, that you've read some, not all. I mean, most of these guys that you work with at universities, they could have put out 15, 20 papers. Or more. Like some people are like hundreds of papers. You just look at their latest stuff. And then sort of like get a good idea. And always suggest, like, so if you're actually going to school, Jalen has a good point here. If you're going to the school itself, suggest meeting with them. Try to set up a meeting, and I would also suggest reading the research of any professor you have. as this can be an enriching, even not, if not necessarily what you want to do. And they will like you a lot. That's 100% true. And a lot of my ideas that I had for research came from looking at a professor's page and was like, hey, I'm very interested in this, this, and this that you've done. You know, what can we, like, if I were to pick a project with you, what would we do? And, you know, like, and they would be like, I mean, I wouldn't say it like that. I'd be a little bit more like, I'm interested in researching. I've read these papers. That's really interesting to me. I really like that. I was like, could you tell me more about it? And most of the time, they're super happy to start talking, just like Jalen said. Excellent advice. But yeah, that's it. And like your situation, Jax, might be a little different because it's distance learning, but I would just be like, you know, can we set up like a phone interview? Or can we set up a phone meeting where we can discuss, you know, what you've done? It's very interesting to me. I'd really like, you know, to spend some more time working on that. And ultimately, that's how you start your graduate program as well. Like your anyways, NC, this is kind of like what some things would be if you would. I know you said you're not. I don't know if you're interested in that or not. But if anybody is interested in pursuing like a work in industry, then LMAG, electricity and magnetism, LMAG. But if anybody's interested, you should really highlight certain things that you have, and like these are things that you could like that they're saying that you could do. Okay, enough of that. Now, if we were to talk about how much they make, starting salaries, you can sort of see where they're ranging here. See, this one kind of confuses me. College or university. I wonder what they're talking about when they say college or university. Yeah, but I think ultimately NC is kind of curious about going back to school too. So we're gonna talk about going back to school soon. I just want to finish this page in case anybody in here is not interested in going on to research. For graduate school, research, sell it too. Yeah. So that's gonna be a big thing about going into graduate school is having research. Having research is one of the most important factors for getting into graduate school. Now, let's talk about graduate school. Let's talk about this one first. I don't think it includes graduate position. If it includes graduate position, the salary is not correct. It's way too high. But salaries for graduate students are... Oh, it includes graduate position. Oh, I see. So it'd definitely be worthwhile. Do you have a link to it, or should we just look it up in a minute? Anyways, let's go over this a little bit. NC, you'll have to take the GRE, and depending on the school, the physics GRE might be necessary as well. So let me put this in chat. NC, just bookmark this page or keep it in your pocket or something. This tells you about the GRE and also the physics GRE, because a lot of schools will require the physics GRE. So like Buffalo requires it. Binghamton University does not. So you can sort of like go through here and see about what you need. And this is kind of like the and this is like your scores. These are, when they say minimum, this is like the minimum average of people that make it in. Not at all necessary to make it into school. The GRE is very quickly becoming something that nobody cares about. Like very quickly, nobody cares about it. Like Caltech is doing away with their GRE. Is that right? Or their physics GRE? Not the general. Anyways, it is crazy that Caltech got rid of it. It's making a huge statement about getting rid of the like standardized testing in general to get into graduate school, which is huge for like anybody who wants to go to graduate school. Getting rid of standardized testing is huge. It puts so much more emphasis on your research, which is ultimately what you should do. So that's where, if you want to look at what GREs are required for the schools, this is a good site to do it. Here we go with a different thing, acceptance rate. Let me put this one in chat. Boom. Acceptance rate is another place to start looking. some of these schools have fake acceptance rates, and maybe I should say faux acceptance rates instead of fake. When I say faux, it's just because, like, obviously if they had 19 apply and 19 admitted, something's up. Like, they just started their physics program, or they had to take a few years off of their physics program, or something like that. That's wild. Anyways, yeah, so it's a huge statement that people are trying to get rid of GREs. It's anyways, the general one might never go away, unfortunately. But the fact that people are starting to throw away physics GREs, like literally say that they're not required, that they won't impact your grade, maybe they might impact your grade, but they're not required, and that they don't really care that much, it's a statement to say how they feel about standardized testing in general. Because if they're not interested in the physics GRE, you know, how it immediately means that they're also, like, slightly less interested in your general GRE than they were years ago. I don't think it's going to hurt anything, okay? So this is a good idea to check out with acceptance rates. Obviously, like I said, you might have a few outliers, but this, like, these look like they're pretty legit. Wow. I don't know about Bowling Green State University. Bowling Green. You accepted 60 and only 8 showed up? That's wild. So this one might also be kind of a fluke because they might have thought. So what? This is kind of the complicated. Let me go down to Binghamton. Okay. Look at. Binghamton has 35.71% acceptance rate into graduate school. Okay. Why? We have 42 people apply. Binghamton has a great program. Really, really, really solid program. Because of that, we only have, but there's not like there's not tons of money. There's not tons of professors. The department just moved to a bigger place with a lot more room to do a lot more stuff. Okay, like that. If 42 people apply, we can offer like 15 people spots, because roundabout somewhere around half or less, like slightly less, will take us up on the offer, and that's almost fairly statistically like accurate always. And that's kind of the point. So like this number, it's a little bit odd because like sometimes you have schools like Appalachian who are like, well, we don't often get many people, okay? So we're gonna take, you know, if we have 5 spots, we have 19 people apply, you kind of have to issue like quite a fair deal of those to get the 5 spots filled. And it just so happened that out of the 19 people that applied, 17 said yes. So what does that do? Well, that kind of, I mean, like, that kind of could get kind of messy because, like, you only have 5 spots, and here you are now. All of a sudden, you have to have 17 spots. But like the and then you make do. You go to the you go to the, you know, you go to the people, the board and stuff, and you'd be like, okay, well, so you know, we were supposed to have 5, but 17 said yes, and it was kind of a fluke statistically, but you know, that's what we have now, so we have to deal with it. And the board will, you know, the board will take care of it. And then usually what that means is then the program will be shut down for a few years. Like they won't be able to admit anybody new until they can get back on track. And then you just pick it up again and go. But the downside, the alternative of that is, okay, well, we only need 5 people, so let's only offer 6 spots. Because they were at 19 offered, they got 17. So they're like, okay, well, let's only offer 5 people, or 6 people, and maybe we'll get 5. You know? You offer to 6 people, you know, it's not a very large school. There's a good chance that all 6 people are just going to say no. And then what do? Except you have no new graduate students coming in. You have no TAs coming in, because first and second year graduate students are the ones who are mostly going to be teaching. And now you have no TAs. You have professors whose groups are going to be graduating with nobody coming in to take over. It can get kind of messy. So what do? You make your best guess at offering a certain amount of spots and then hope that the right amount fills. Okay, Jalen says, from my understanding, the general test is required by the graduate school and upper admin, but the physics admissions committee could care less about them. Exactly, yeah. And that's what we have been told by faculty here in those schools I applied to, the professors here. Yeah, so for me, like, is it the University of Arizona is making us panic about? They were afraid that COVID would make the number of accepted the offer too high. So they said they might rescind offers and scared all of us. I don't think they ended up rescinding any offers though. Yeah, I've never heard about rescinding offers. I heard that would be an awful thing to do. That would be an absolutely awful thing to do. And it's a scary thing to do. Because, I mean, like, you are putting yourself out there. I mean, we offered 15 people. And Binghamton's a big school. So Binghamton could handle getting 15 people. But look at University of Massachusetts. 63 offers. Can you imagine if all 63 people said yes? That graduate class coming in would completely dominate the entirety of that department. I mean, 63 fresh undergraduates. They're not like, I mean, look at, what do you got here? Let's look at like Columbia. I guess I need more than that. Columbia. Nope. Whoops. Oh, how do I go down? Columbia University. Oh, wait, what? Where's they're enrolled? And flukes happen, I get it. But I mean, like, that's so brutal. Look at that, Ohio State University, 41 entered, but they offered 121. Ohio State University's physics department is massive. So that's, but look at that acceptance rate here. Where did Ohio go? Did I lose it? What order is this in? There it is. 30% acceptance rate. That's low. That's very low. What's the lower ones even? Dang, look at that. Brown University, 39 out of 295 entrances. MIT, 107. Oh, is this the one I'm looking for? 500 applicants and they took 10% of them. Holy. Yeah, to change the sort, but I probably could change it by name. Harvard University, Stanford, look at all these. Wesleyan Physics. They offered it to 3 people? They must. Anyways, this isn't very helpful, I suppose, to your question, NC. It's just interesting. So let's talk about the most important things, and then if anybody else has any ideas on what they think is important, then they can chime in here. But it should look something like this. No, don't end the meeting. What are you doing? Don't do it. Let's do scene transition. And then, no, don't end the meeting. Okay. We're gonna make a list together, okay? From people who have what am I even looking for? Is there no notepad? Okay, you're gonna have to help this old man out. I can't find a notepad. Old man. Okay, I just typed it. I just found it. Alright. What happened here? Oh, I clicked on it multiple times. Okay, so let's make this a little bit smaller. Did I just close it? No, I didn't. Okay. So, list of, oh, okay, let's see, rank. Okay. Most important thing in my mind, and I think Jalen will agree. Anybody else chime in and agree? RPG, are you in graduate school, or did you get accepted to graduate school, or are you still working on it? Research. Number one thing in my mind is research. 100%. Almost can decide for you if you're going to get in or not. Is research. Like I couldn't stress enough how important research is to getting into graduate school. And if anybody has any other ideas, feel free to chime in. Okay, well, actually, it's really nice to hear. I have a few years of research doing computer simulation, extra cold, many bodies, quadrupolar molecules. I've been presented at 3 different conferences, in-house, regional, international. I won an award for the best poster at a regional conference. That's huge. Yeah, that's huge. That is going to boost your chances by a long shot. It is 1 C and 2 M's. I was right. This guy. But anyways, would you agree with that, Jalen? Would you say that next up would be recommendation letters? And then follow that by the, whoops. So if you don't have a research project already at your school, I don't think it's a likely chance that you're going to get in. I think GPA is 3rd. I think if you have and here's my clause from that, okay? So there's a little bit more of a clause to this, okay? If you Yeah, recommendation letters are huge. So here's the clause about recommendation letters. They matter if they are relevant. If they are not relevant, then I would probably put them below your GRE score. Why? Because if the person who's looking at it, if the school, we'll call it the school, if the school who's looking at it has nobody who knows your recommendation letters, then they don't care. It could just be anybody. So, recommendation letters. Hi, Abdal. How to study for the GRE. Which one? Well, I mean, obviously practice. Okay, so there's. I'll get to the. I will absolutely answer that in just a second. That's a great question, by the way. Let me finish my thought about the recommendation letters, and then I will put for Jerry. Wait, where's my mouse? Okay, so I think GPA is an indicator in the sense if trending down or bad, upper level physics equals bad. If trending up or good, and upper level physics is good. Besides that, not too important. Correct. I agree with that 100%, Jalen. And that's the only reason why it goes above the GRE is because I really don't think people care that much about the GRE. They really see the trend in your grades and just make sure that your upper level physics grades aren't terrible. If your upper level physics grades are good, and then they don't really care. So like you could have like a 2.8, but like still have like 3.0s in like most of your upper level physics, and I don't think I don't think they're gonna care that much that your overall GPA was 2.8. As long as your upper level physics were high, you know what I mean? So I think my GPA graduating was 3.17, and all of my physics classes were above 3.0 except for one, maybe two. Maybe 2 physics classes were below 3.0, but they were still upper 2s. And the rest, you know, were either high 3s or like mid 3s or whatever. But I was also trying to compensate from some of the classes I took when I was younger, so I screwed myself when I was young. Of course, Abdal, I love to be around and answer physics questions. So to finish the clause about the recommendation letters, if your recommendation letter writer has connections at the university, it can be equally as powerful as research. My grades, my lowest non-physics, non-math classes were 3.9. Oh wait, 3.5 in rest. Yeah. So you had a really nice GPA though. 3.7 is really high. 3.9 in math, 3.8 in physics. That's so good. Do you think having double major in math is significant? It would be lower than the recommendation letters in my opinion. Again, like, so the most important thing is research. How successful were you at researching? Okay, that's the most important thing, because nobody's good. Because like I said, when you go to graduate school, you're gonna get hired by somebody. Probably, like, I won't be hired by my advisor. He's in his late 70s. He doesn't have any grants anymore, so I'm not gonna get hired by my advisor. But so I'll just teach, which I like teaching. That's why I do this, because I like teaching. So that's not a problem. Okay, or I'll go for a fellowship or something, whatever. But most graduate students get hired to research, probably in their 3rd or 4th year, if not earlier. If they're super promising, then the person might want to hire them immediately. But most of the time, they have to teach for a few years, then they get hired as a research assistant. You are potentially someone's future employee. So you have to market yourself like that. So that's why research is so incredibly high, because someone's going to look at you and say, can I actually get this guy to do anything for me? Like, am I going to pay him to whatever it is that we make, not very much, $26,000 or whatever a year. Am I going to pay him that much money to actually do something for me? Or is he just going to, like, just be extra weight? So you have to market yourself as someone who's going to bring this one single professor success. So what does that mean? Like, that means that your research has to be they want completed research, so they want you to actually have written stuff. If you haven't written papers, no biggie. That's not a huge deal. But like competitions, presenting your research in poster contests, or just at poster sessions, whatever. It doesn't have to be a contest. Actively going places. And then here's the clincher. This is how recommendation letters can be so much important. Contact your old advisor. Say, like, I'm looking at this school. Like, is this a school that you, like, is this, like, I don't know if you want to be like that. It depends on how formal you are with your advisor. Like, I would be fine asking my undergraduate advisor if he had contact at, a different school. It'd just be like, hey, do you have contact at this school? Because, like, I'm interested in going to grad school there. And to see what he says. He might be like, I don't know anybody there. Or he might be like, oh yeah, I have like such and such, just like a really close friend of mine. I will happily write you a recommendation letter, blah, blah, blah. They'll be very interested. Jalen, somewhat important double major in math. I think it's almost expected for physics majors, some degree. I do theory. In my experience, it helps so much with understanding what is good in physics course. I got to this is so loud in my ear. Okay. I just completed a major naturally by taking additional courses with the help of research. Yeah, so for me, I actually, because I was going late and I just didn't have the ability without going to school for another like year and a half at least to get a math degree. So what I did is my school has something very specific where it's called a mathematical physics major. So it's a bachelor's of science, and really you're trading labs for math classes. And you also have to do, like, you have to take certain math classes that are more advanced than the normal physics math classes. Like, you have to take, like, special, whatever, partial differential equations or whatever. I'm 31. 31? 20, yeah, 31. I will be 32 before the end of the year. I went back to school at 28, graduated with my undergraduate at 30, and then immediately started graduate school. And I plan to be done with my graduate school by the time I'm 34. But that's just a goal. We're shooting for it. Shoot high. Yeah. And then I won't be that far behind anymore. Maybe a little bit. But right now, a lot of graduate students are over 30. So I don't feel like I'm behind. There's a lot that are under 30, but not by much. So I feel pretty comfortable where I'm at. When I was an undergraduate, it was weird. I will probably be getting my master's in physics. I don't have my master's in physics yet. I am in a PhD program to go, in America you can go directly from your bachelor's degree to a PhD, but you can get your master's along the way if you do the right things. So I'm presenting my preliminary, which is like my thesis topic, this spring. When I present my thesis topic, then if it's written well enough, then I can apply for a master's that is specific to that topic. And then I'll do my rest of my degree in the next 2 or 3 years after that. But the math is nice, but I was able to, like I said, I was kind of able to lump it into one. I only had to do the general one. At my university, they didn't take the physics GRE. I had already missed my opportunity because I didn't realize that I was going to graduate until after the exam. Just because my case was very, very specific, so I didn't realize I was going to actually have my bachelor's degree that year. I thought I was going to have to wait until the following year. I did not do the best on the general GRE. I was 1 point above average for my university, which is not very high in general, percentage-wise. I don't know my exact numbers, but I think it was mid to upper 70s. Like I said, I don't remember exactly. I think I got like 78, and my average was at my school 78 percentile. And this is just quantitative because the other parts don't matter. They were good. They were just average. They weren't anything special. Nobody cared. It was the quantitative that you really care about. And I think I got like 78 percentile, which is low for physicists. Then it's also like 1% above the average for my school. So I was like above average for my school, but not by much. Okay, so the GRE. The general GRE. If everybody agrees with this setup, then I'm going to say this is... So the quantitative GRE. So one thing is, do some research on YouTube, honestly. Great advice on YouTube. That's where I got most of my advice from. Here's the thing about the GRE now, quantitative, is it scales with difficulty. Or it scales with how correct you are. So, I remember the first few questions in my quantitative were dirt easy. Okay? It changed so quickly to number theory that I was just baffled. Like, and I'm talking like legit number theory. Like, there was sets of numbers with things missing, and I had to like determine the numbers in the set. And it wasn't like very simple sets. It was like, you know, it was like the sets, I feel like the sets were like things that I've seen when I actually took real analysis classes. Like, they weren't easy at all. They weren't like, you know, Fibonacci style series where it's just like, you know, 1, 1, 2, 3, 5, 8, you know, whatever. They were like, they gave you like 6 numbers and like 3 of them were missing and you had to figure out what they were. It was brutal, and it happened so fast, and it completely took me off guard. And I still, even though that happened, I still got like really high. So apparently, like, the better you do in the beginning, the harder the questions get, and the higher you can score. So like, it got really hard really quickly, but I still like pounded through it, and that's how I ended up getting my score. But I was a little bit shocked. So here's what my advisor, who teaches, so my advisor right now teaches a course on the general GRE and the physics GRE in the fall. It's like 2-credit course for people who are going to take both GREs, okay? And this is what he told us about the general GRE. Take practice exams, maybe 2 of them. The way I scored the PGRE is weird. I didn't study for the quant section except for the night before, and I was surprised by the scaling too. Yeah, the scaling gets kind of difficult really quickly. But it doesn't matter because the score is going to be higher. So, like, I think for me, the worst part is the panic, because I did not expect that difficulty. Because they were like, oh, it's going to be like, if you took calculus and some statistics, you'll be fine. And I was just like, oh, okay, calculus and statistics. And then I see, like, this random, like, bunch of numbers with a bunch of them missing, and then I have to figure out what numbers go in the holes. And it was not at all easy. Like, how's it going? Oh, you there you are. Thanks for following. So here's what he told me to do. He said, spend 3 hours studying. This is what you spend the 3 hours studying. Format. That's it. 3 hours going over format. What does it look like? What do all of the sections look like? You can do it in 3 hours if you sit down and just get a couple, like, materials, go over what the verbal looks like, what the written looks like, what they expect of you, and then quantitative. Basically just subject material, okay? So after you spend 3 hours, you can sit down and do it on a Saturday morning before stream, and then come to my stream and tell me how it goes. Then, after the 3 hours looking at formatting of the general GRE, do a couple practice exams, 1 or 2. I only did 1. Like for me, it was kind of like a formality because I was pretty much, like I said, I had already got my project. I was already working on my project. So it was more of a formality. And then the only thing that my advisor might have been like, how did you score so badly if I did bad, but I didn't. So, and then he probably just would have made jokes about it because he's really, like, he's probably one of the best people I've ever met in my entire life. One of them, not the best. That's my wife. That's genuine though, even though that was a goofy smile. Anyways, where was I? Okay, so yeah, 3 hours going over format, spend a couple hours doing practice. And I think that's it. What do you think, Jalen? Do you have any other advice? I mean, clearly I'm pretty sure you did well too. Yes, so I hope so. It's a scary process, but it doesn't have to be. Like, you can do it, so, okay, here's another little anecdote, okay? Another little anecdote. I just applied to the GRFP, which, by the way, if you're going into graduate school, you should absolutely apply for the GRFP. It doesn't matter what you think about whether or not you'll get it, apply. Do the research, put in a huge effort, and whether or not you get the GRFP, apply. Okay, because it is great. It's hard to get, but it's great. A friend of mine had a lot of these tricks and crazy things to do. It's the Graduate Research Fellowship Program as part of the NSF. We all have to, Jax. We're all invested now. We're all invested in this NC. There's the NSF GRFP. If you're gonna go to graduate school, you should absolutely apply. Abdallah, it's not the end of the world if you don't do research. This is it's certainly not the end of the world. It's certainly not the end of the thing. You will get accepted and you won't have a program. If you get accepted, you won't have a program. That's it. So, like, if you have a lot of research, it's great. It looks amazing on your review if you have tons of research. Applications are pretty cheap. I think mine was probably waived. Most schools can waive a bunch of them. Yeah, so if you want to do a PhD in any field, usually research is the best, even accounting. Just because people are interested in that. And like when you graduate with a PhD, so when you graduate with a PhD, what is your PhD? Your PhD is a specialization. It's a specialization of something. Like you are very good at this thing, and someone is very interested in that. Yeah, I think mine was free. They most universities will waive the first batch of them, and then after the first batch, then they start charging. And at least that's how SUNY works, I think. So out of the 40, they might waive 20 or 25, and it's kind of dependent on whether or not they're gonna when they get the application, they'll see the person. They'll be a professor might be I want that person to come here, so I'm gonna waive their application fee just to sort of give them a little boost. Yeah, I don't really know what the field is like for accounting, Abdal. I don't really know what it's like. But if you don't have any research yet, it shouldn't be a big deal, especially if you already got accepted for a master's. Maybe that will come after. Anyways, what I was gonna say to NC, now that I thought of that completely out of your hands thing, And see, we get to this point where we're applying, like, so with these fellowships and applications in general, this is like a general rule of thumb that was brutal on me recently, but it's just, that's the way it is this last year. Okay, because you apply for these fellowships, you apply for them in October, and you don't hear back until April. Graduate applications are usually better than that, but still, like, they're really long. And it's this thing where, like, you put in as much effort as you can afford to put into it, and then you send it away. And with it, you try to send your worries away too. And it's hard. It's so hard. But, like, sometimes that's what you gotta do. And, like, it's, like I said, it can be very difficult. But sometimes you just send your applications away, and you try your best not to think about it for a few weeks, months, however long it's gonna take. Like, I remember the GRFP, I sent it away in October. I felt this huge burden lifted off my shoulders. And I thought about it every once in a while, kind of like, oh, I wonder if I'm going to get it. I wonder if I'm going to get it. How excited will that be? You know, if I get it, blah, blah, blah. But then once March hit, it was like every single day. I was just like, oh, man, I really hope they like me. I hope they want to pick me. It's just hard. I said earlier that it's unfortunately very important who you know. Yeah. Jalen, do you have an idea of who you're going to work with? So another one of the big things is, like, another one of the things that we get asked a lot, graduate students get asked a lot, is, like, who do you pick? Like, what do you let dictate your choice? Is it the professors or is it the university? And, like, that's a very, very hard thing to say in physics. It's really difficult. And I'm going to speak pretty specifically to physics for this. But it's like, okay, so yeah, so we have this choice really to make, and are you going to choose a university based on professors or the university? And it's really like a balance. It's got to be a balance. If you don't have anyone specifically, you're like, I have to work with this professor, then you need to have a balance. Professor Bashar, I was looking at a few specific research topics and found people who did those things. Yeah, and that's very good. And, like, you can, if you know what you want to do that. Like, if you know 100%, you're like, so for me, like, I wanted to do particle physics or gravitation. That was it. I was not interested in condensed matter. I wanted to do pencil and paper theory, i.e., like, I wanted to be separate from computers. Not even, like, pencil paper theory where I check things on computer, or pencil paper theory where I go to a computationalist and say, so my dream is to go into the intersection of computation model, QFT, and GR. Not exactly sure what that would be explicitly, but it's the dream. Maybe working with BEC simulations on the space station. That's pretty cool. I mean, that's pretty specific. Computational model, QFT, and GR. There's so many programs that have computation modeling for QFT. Absolutely. So many programs. I know there's a lot out here. I can't even imagine how many, like, just one bigwig that immediately comes to mind. Now I said bigwig because I read it from earlier. That's funny. But one person that comes to mind immediately is Preskill. He does computation modeling, and he also did QFT for a long time. I'm pretty sure he does, I'm not sure if he does just quantum computing now or if he does computational QFT. But I mean, like, he's like super bigwig. He's super up there. So what is the job of a Bachelor in Physics? Honestly, Abdallah, they can be like pretty much anything. Like, okay, I always say they can be pretty much anything. It depends. I've known, like Jack said, she knew people that did marketing. I've known people to work in government, that work on, like, government contracts. Engineering, a lot go into engineering. But, like, they can go into so many different fields. If you have a physics thing, here's what you're marketing. If you have a physics degree, this is what you're marketing. Thanks for following. Welcome to the channel. If you have a degree in physics, this is what you're marketing. You're marketing your problem solving. You are one of the most generalized problem solvers. And I mean, like, problem solvers over all fields of natural sciences. And like you could specify, like research could be in something very specific, like it could be in quantum computing, or it could be in density functional theory, or something like that. But you are literally just a very high quality trained problem solver, and that's it. That's what you are. So it depends on what you want to market, what you want to go after. And like if you market yourself properly, go to internships, do research, you could absolutely go to do anything that you really wanted, as long as that job had problems that need to be solved, and you could market yourself as someone who could solve it. Hi Slayer, how are you?